So, this used electromechanical system sensors. They had high accuracy, high reliability. They can also be embedded in the structure. It has a capacity to measure the damage at early stage. To design an alert monitoring system. So, this was first proposed as an idea by Chung et al. In 2004. The sensing unit was designed with RISC microcontrollers, MEMS based accelerometers. Showed a fast computation capability for data processing, because it has inbuilt microprocessor. The sensor is shown in this figure here. Details can be seen of the development. Can be seen Lynch et al. 2001 is related to statistical pattern recognition, in brief SPR. So, in SHM scheme, a module was developed which can do operational evaluation, data acquisition, feature extraction, and then a statistical model based on that. I mean, all are required to be now developed. That is the next stage of advancement happened in wireless sensor networking. So, coupling of integrated hardware approach, the transmission board was developed by Motorola, Neuphone, which provided the wireless access point in the sensing unit This had a transmission board online. The unit is shown in this figure. More details can be seen at Farrar et al. 2006. The first integrated data acquisition system which has telemetry and processing systems for structural health monitoring scheme. This system showed better capabilities other than the different systems used at that point. The new development came into play with use of iMode 2, which is designed and developed by Intel this provides a powerful computation tool, because we are talking about the statistical pattern recognition. So, computation tool was important and also a powerful communication platform. So, the advantages were computation tool and communication platform, which were the highest demand in SHM application in the recent past. The board had signal processing unit, and high resolution data acquisition. And they said these sensors are very useful in large applications, test ship, that is MVOOCL Europe, which travels from Busan to Jeddah. This was first commissioned in that. The structural health monitoring measured the hull stresses, and it also had the wave monitoring system. The data was validated with detailed experimental numerical analysis and found to be very efficient. So, these comparisons were reported by Yu et al. In 2006. A new wireless sensor system Narada wireless hull monitoring system which was used in the sea fighter FSF-1. So, the picture shows it measured the strain and acceleration response of the vessel of the sea fighter. This unit has 20 sensor nodes. The data received from this were used deflection shape of the vessel, Lynch et al. 2009. So, that is the data what we have. This is the Narada wireless sensor networking has seen high advancements, more advantages, wide applications at different fields, like for example, construction engineering, bridges, tunnels, naval architecture, ships, essentially warships, reservoirs, buildings, etc. So, we have seen the major advantages of wireless sensor networking. We have seen the technical specifications of the wireless sensors compared to the wired sensors. We have also seen how they are compact, how they are multifunctional, and therefore, how they are fast and simple. In the future lectures, we will discuss about more on the layout of the design of wireless sensor networking on a lab scale, which has been done to really analyze two parallel networking systems to compare the advantages of each one of them in terms of system configuration, acquisition of the data, transmission capabilities and data management, etc. Thank you very much and bye.